This week we're exploring Stoke Space, a US-based space startup that's pushing the boundaries with its second stage technology to build a completely reusable orbital vehicle. They've pinpointed three major hurdles in space travel: the difficulty of reaching space from Earth, maneuvering once in space, which includes tasks like space tugs and refueling, and the safe return from space. Existing solutions to these problems are far from ideal. Launches are still very expensive compared to other modes of transport, in-space refueling is virtually non-existent, and the amount of mass that can be brought back from space is severely limited. Stoke Space is tackling these challenges head-on by designing a rocket where every part, not just the first stage, can be reused. Leveraging the capabilities of fully reusable rockets could dramatically lower the cost for accessing, navigating, and returning from space, potentially reducing the cost to orbit by a factor of 20, and thereby fueling the growth of the space economy. They are developing rockets and space vehicles that can be reused quickly, much like commercial aircraft. The company's technological advancements have been supported by investments from the US Space Force, NASA, and the National Space Foundation, and various government and private entities, totaling over $175 million in funding since its founding. Currently, Stoke Space is expanding rapidly, having grown from 100 to 140 employees since early 2024. This funding is being channeled into completing the development of their first stage rocket engine and structure, as well as an orbital version of their reusable second stage. Additionally, they are constructing new facilities at Launch Complex 14 at Cape Canaveral Space Force Station in Florida, where they have been granted exclusive use by the US Space Force for their orbital launches. Next, let's look at the technology Stoke Space is using. Let's have a look at the upper stage from Stoke Space. You'll notice it's equipped with 30 rocket engines positioned around its base, alongside an actively cooled heat shield. This design makes it perhaps the most distinctive second stage ever developed by a commercial space startup. The goal? A 24-hour turnaround time, because as the CEO pointed out, rockets earn money when they fly, not stationary on the ground. The upper stage showcases an innovative propulsion system where a large pump feeds propellant to the 30 combustion chambers circling the heat shield. Here, the exhaust interacts with a unique metallic liquid-cooled heat shield, improving efficiency by turning the setup into what's effectively an aerospike engine. So, what's an aerospike engine? Unlike traditional engines with a fixed bell nozzle, an aerospike uses a central spike or ramp where exhaust gases expand outward. The clever part is that the surrounding air pressure acts as an extension of the nozzle itself. As the rocket climbs and the air thins, the exhaust flow adjusts automatically to these changing conditions, which means the engine remains efficient across various altitudes. This adaptability of the aerospike design means better performance from the ground all the way to space. It's like having a self-adjusting nozzle, which not only conserves fuel, but also potentially increases how much payload the rocket can carry. Let's take a look at some of the features of the second stage vehicle. Capable of sending 5,000 kilos into orbit, although according to documentation it could be up to 7,000 kilos in expendable mode. Designed for minimum refurbishment between flights, unlocking rapid turnaround, refit, refuel, refly. Direct access to geotransfer orbit, and trans-lunar injection and other high-energy orbits. Return from orbit to launch site, precision-powered vertical landing. And 100% reusable payload fairing. 180 degree by 360 degree deployment hemisphere. The second stage also has the highest performance engine in class. Thanks to the use of the liquid hydrogen and liquid oxygen, the second stage has unrivaled performance. With unlimited restarts, the second stage provides great flexibility in mission architecture, unprecedented in-space mobility, and precision-powered vertical landing. Another feature is the down-mass capability. Stoke Space is focusing on the ability to bring things back from space, which includes capturing and returning debris or assets, as well as handling space cargo logistics. While the specific amount of mass they can return to Earth hasn't been disclosed yet, the CEO has suggested in recent discussions that this capacity might see an increase. We're all waiting to see just how much it can bring back, but the expectations are that it will be substantial. Another great feature is its actively cooled metallic heat shield. Actively, that means regeneratively cooled metallic re-entry heat shield with integrated modular liquid hydrogen and liquid oxygen rocket engine is robust, resilient to damage, and operates with passive failure modes. Next, let's take a look at Nova, the first stage vehicle. The Nova rocket is Stoke Space fully reusable medium lift launch vehicle. Nova, like the second stage, is fully reusable. It's powered by 7 full-flow stage combustion rocket engines. They use liquid natural gas and liquid oxygen. The engines are similar to SpaceX's Raptor engines, using the same rocket cycle and propellants. The Nova vehicle will have return to site or downrange landing capability. Next, let's briefly look at Moses Lake, that's the Stoke Space testing facility. The formula for Stoke Space is test, fail, and fix. They move quickly from idea to prototype to production. So the team has a big focus on testing. If they fail fast, they learn fast, and then they fix it. Stoke Space started with the second stage first. Their testing began with the novel design of a reusable second stage. That's the part that everyone else throws away. Located only 3 hours from manufacturing, the Moses Lake test site allows them to test components quickly without unnecessary delays. Stoke Space test every day. Their facility has an ever-expanding section of test bays for component and horizontal testing of Stage 1 and Stage 2 engines. Stoke Space is focused on testing for rapid reuse. Their Stage 2 vertical test stand allows them to test a new engine design built for sustainability. They've integrated and tested an actively cooled heat shield that will be used to reuse the second stage rapidly. Their Stage 1 engine vertical test stand is coming soon. It's currently under construction and designed for testing the full-flow stage combustion engines in the same orientation as they'll launch. Scheduled to go online in the late summer of 2024. Next, let's go over some of the milestones Stoke Space has achieved so far. In March 2023, Stoke Space is allocated Historic Launch Complex 14 at Cape Canaveral. Future operations for Stoke Space will take place where John Glenn took his historic flight as the first American to orbit the Earth. Stoke Space announced they've been allocated Launch Complex 14 at Cape Canaveral Space Force Station in Florida. On February the 20th, 1962, John Glenn became the first American to orbit Earth when he launched from Site 14 on the Mercury Atlas 6 mission. He successfully circled the Earth 3 times in the Friendship 7 capsule before re-entering the atmosphere and splashing down in the Atlantic Ocean. Andy Lapser, the co-founder and CEO of Stoke Space, said, "We're standing on the shoulders of giants, and we are beyond humbled by the historic significance of LC-14. The opportunity to reactivate this site is a profound responsibility that our entire team holds in the highest regard. As we bring LC-14 back to life and carry its legacy into the future, we will be sure to do so in a way that preserves its existing history and pays homage to those who came before us." In September 2023, the Hopper has landed. Stoke Space marked a significant achievement at their Moses Lake test site in Washington with the successful vertical takeoff and vertical landing of their reusable second stage rocket, named Hopper 2. The test flight reached 30 feet and lasted 15 seconds, showcasing their innovative hydrogen-oxygen engine, an actively cooled heat shield, and a differential throttle thrust vector control system. This was the concluding test of the Hopper program, where all objectives were met, validating their unique approach towards creating rapidly reusable space vehicles. Stoke Space set several milestones, including the first vertical takeoff and vertical landing rocket test. Despite not facing actual hypersonic re-entry conditions, the heat shield was tested at full expected heat load in simulations. Looking forward, Stoke Space aims to develop a completely reusable rocket with a 24-hour turnaround, focusing now on enhancing their first stage as they progress in their development program. In June 2024, Stoke Space completes first successful Hotfire test of full-flow stage combustion engine. The engine will power the first stage of Nova, the company's fully reusable medium-lift launch vehicle. Reaching this technical milestone represents a major leap forward for Stoke, as the company is now on track to deliver the most robust, fully and rapidly reusable medium lift rocket in the world. Stoke engineers completed the first Hotfire test of the engine on the 5th of June at Stoke's testing site in Moses Lake, Washington. During the test, the engine successfully ramped up to its target starting power level, going from rest to producing the equivalent of 350,000 horsepower in less than 1 second, before holding the power level and shutting down. The engine is designed to produce over 100,000 pounds of thrust at full power. The full-flow staged combustion engine has long been considered the pinnacle of rocket propulsion technology because of its unmatched efficiency and performance. The advanced rocket technology enables Stoke's reusable vehicle to perform missions to and from a wide variety of orbital destinations, while still operating with the conservative margins needed for a long service life. Notably, Stoke's team designed and manufactured this first stage engine in just 18 months. Over the remainder of 2024, Stoke expects to mature its engine and vehicle design while scaling operations for orbital launch. And finally, let's cover upcoming events for Stoke Space. Looking at the Environmental Assessment Report for LC-14, we can see in the launch schedule section that 2 launches will be conducted in 2025. It's anticipated that 10 launches will be conducted in 2026. In the meantime, we can expect to see more Hotfire tests of the first and second stage engines. The vertical test facility for the first stage vehicle should be close to completion at Moses Lake, so we can expect to see vertical test firings of their full-flow stage engines soon. As always, we'll keep you informed about this exciting new space startup and their innovative technology. Thanks for watching. Don't forget to hit that like button and subscribe to stay in the loop on the latest developments from space startups. The space startup scene is more than just launch providers. It includes commercial space stations, in-space operations such as orbital tugs, refueling stations, orbital debris removal, power generation, lunar infrastructure, and asteroid mining. From the latest news on Earth to the latest discoveries in orbit and beyond, we've got you covered. See you soon.